Let's continue now with using the rules of exponents. The rules of logarithms in order to simplify some logarithms on numbers. Remember that the result that you will get when you do these simplifications is going to be either a logarithm that you can calculate using your calculator, or it is possible that you can come up with a final answer that is a single integer, an actual number. So let's say it together. How do we apply our rules again when we try now to combine logarithms in order to get a final single logarithm, because this is what it means, simplify the logarithms into a number or a single logarithm. You have first to use the rules on this in this order. First the power rule, then the product rule, then the quotient rule. Now to interchange product and quotient rule, it doesn't play a big role if you are careful and you apply correctly the rules of multiplication of variables. One thing that I would recommend is that if you have radicals, and it's not necessary that you will have that radicals, then make sure that you change them to rational exponents. They are much easier to handle. So the first thing that I want to do is, as I said, I would apply first of all the power rule. Now, as you can see, there is none of these terms that I have is multiplied by a number next to it, a constant next to it. So there is no reason, there is no way that I can apply the power rule here. So I'm going on to product rule. So I can take basically the two numbers, the two logarithms that I can add here. Now, how do I apply the product rule? I apply the product rule if I have two logarithms that they are added together. Now, be very careful, because right here, if you decide, let's say, to apply the product rule to the second and third term, this is not possible. Why? Because although you have a plus and you may be misled here that you have an addition, the truth is that you have a minus here. So basically, the combination of those two logarithms is a division, not an addition, and the logarithm that you subtract is this one. So in order to apply the product rule here is that basically the first thing that you need to do is consider all those logarithms that they have a plus sign in front of them. So which are these logarithms? Is the logarithm of 6 plus the logarithm of 2 of the number 20. Now again, what you consider in order to apply your product rule are the signs of the logarithms. This is a logarithm with a plus sign, this is a logarithm with a plus sign. You add those two logarithms first and you apply the product rule. You leave all the negative signs for the end, no matter where they appear in the order of the logarithms in your algebraic expression. So this, with the product rule, it will give me log with base 2 of 6 times 20. And this is going to be the number 120. So I have log with base 2 of 120 here. So now I took care of this one and that one, and if I replace them by their equal, log with base 2 of 120, then I rewrite my expression like this. So now I have two logarithms and I have their difference. So now I'm ready to apply the quotient rule. And the quotient rule will be the combination of those two logarithms with the same base 2, and at the numerator I will have the 120. Why? Because this is the logarithm that has a plus in front of it, divided by the logarithm that has a minus in front of it. So divided by 15. And I need now to simplify 120 by 15. So I need to perform a division. So if you apply the division here, this is nothing else than the number 8. So you have the log with base 2 of 8. Now, as we know, the 8 is the third power of 2, so we can rewrite this logarithm as log of 2 to the third. And the result of that will be the exponent of the power with base 2, and this will be the number 3. So that will be our answer 3. Okay, so the only part that can be confusing in these type of expressions is to decide which logarithms are added together. So as I said before, you always look for the logarithms that they have a plus in front of them, and these are the ones that you combine first with the product rule. You leave all the minus for the end in order to apply the quotient rule step by step. Let's look at this problem right here. As you can see, there is no logarithm with a minus in front of them, so we shouldn't worry about the quotient rule. But there is a constant, the 1/2 multiplied by the log with base 6 of 9. So this means that I should apply the power rule. And this gives me log with base 6 of 9 to the 1/2. Now, 9 to the 1/2 is nothing else than the square root of 9, and the square root of 9 is the number 3. So what I have right here, if I want to simplify this further, is the log with base 6 of number 3 plus the log with base 6 of number 12. Now I can apply, so right here I applied the power rule. And at this point, I need to apply the product rule. This will give me the log with base 6 of 3 times 12. This is equal to the log with base 6 of 36. 36 is the square of 6, so I can rewrite that as log with base 6 of 6 squared. And the exponent here for the power with base 6 is 2. So the answer for that question is 2.